Hello everyone, welcome back to College Algebra. This is section 3. We are finally moving on from section 2 on to section 3, order of operations. Now that I have covered the basics of arithmetic, adding, subtraction, multiplication, division, and exponents and square roots, we can move on to which order how we perform these things. You see, not all equations or not all questions or problems in math will have just one operation, such as addition or just only multiplication. Most problems in mathematics will have many parts to a formula or to an expression. And this section is meant to help us to understand which order these operations are done. Going at this in any order will almost always yield a wrong answer. There is a correct way to solve a problem. For instance, if you decide to add two numbers together before using multiplication, you will get a wrong number. For example, 2 plus 3 times 4 plus 2. Let's say we wanted to solve this equation from the left to the right. We wanted to read it just as if we was reading a page in a book. Let's say we start right here. We end up with 2 plus 3 equals 5 times 4 plus 2 equals 8. And 5 times 8 equals 40. Let's do it another way though. What if I said you're supposed to multiply before you add? What happens then? Will we get the same answer? Let's find out. We have 2 plus 3 times 4 is 12 plus 2. Now, we can just add all these together and we'll end up with 16. Well, wait a minute. These do not equal. You can't go about simplifying an equation or a formula in any way you want. And there's reasons for it, some of which are a bit more complicated to explain here. They will make a little bit of sense when we start to work with polynomials. But for the time being, if there's a multiplication problem, you must multiply first. If there is a division problem, you must divide first. You can't just add and subtract before doing anything else. With that said, if you've been through algebra at some point, you would have come across an acronym called that we've known as PEMDAS. P-E-M-D-A-S. PEMDAS. We often memorize it by saying, "Please excuse my dear Aunt Sally." What it's an acronym for, however, I'm going to go ahead and write it sideways. PEMDAS, what it really means is parentheses, exponents, multiplication, division, addition, subtraction. Think of it as 3 sets of 2s. Normally, you would do these sets at the same time. You would do parentheses and exponents together, then you would do multiplication and division together, and then you would do addition and subtraction together. So, let's start at the very top. I'm going to leave this right here for as long as I remember, just to help us remember. Starting with parentheses, groups. Groups in algebra, in elementary algebra, not advanced algebra. Groups in algebra, we are talking about groups that are held in parentheses, groups that are on a numerator and a denominator, and groups that are under the radical sign. 3 kinds of groups we are going to work with. These types of groups, you want the first step in solving or simplifying a problem is going through the groups first. And I should explain simplify. What this means is to make our question, our expression, as simple as possible. No one wants a complicated expression. We always want it to be as simple as possible. That's why you add two numbers together. I don't want to look at 2 plus 3. I'd rather look at 5 because it's just one single number. So, groups. Always solve things in groups first. For example, let's say we have 2 plus 3 minus the square root of 3 plus 1. The first thing we do is we work with the groups. We have two groups right here. We got group A and we have group B. Let's solve group A first, or let's simplify group A first. So we have 2 plus 3 equals 5. Minus, now we can move on to group B. The square root of 3 plus 1 equals 4. We can't solve this yet. We can't do the subtraction yet. 5 minus 4. We can't do that yet. Why? Because there's still an exponent in this equation. Remember, a square root is simply the inverse of an exponent. So we consider square roots to be on the same level as these exponents over here. So now we solve for this exponent, or this square root. We have 5, let's bring this up here, minus the square root of 4 is equal to 2. Now we can finish our simplification. 5 minus 2 equals 3. Did you see how we started with the parentheses and the groupings together? Let's try another question. This time we'll add a little bit more to it. Let's say we have 7 minus 3 times 2 plus 3 plus the square root of 9 times 3. Alright, I see two groupings and some things on the outside of the groupings. Always, always, always start with the groupings. So we have 7 minus 3. This gives us 4 times 2 plus, we have 3 plus the square root of 9 times 3. So we go on to keep this parentheses up, and we have 3 plus the square root of 9 is 3, close parentheses, times 3. Alright, let's stay. We can do other things now, but let's keep it simple on ourselves and stay inside the parentheses. We have 4 times 2 plus 3 times 3. 3 plus 3 is 6 times 3. So we can't add yet. We can't, even though we added inside the parentheses, now we're done with the parentheses. We move down. I don't see any exponents out here. Now we move on to multiplication. So 2 times 4 is 8 plus 6 times 3 is 18. Now we have 18 plus 8 equals 24. So let's do a little bit more. Let's make this another step higher. Remember, it doesn't matter how complicated a problem is. If you take it one step at a time, you'll find that every one of these problems that we will be doing is easily doable, no matter how long or how complicated it looks. One step at a time. Let's say we have 3 minus 1 squared plus 2 plus 8 divided by 2 squared. A little bit more confusing, a little bit more complex, right? It's super easy. Like I said, one step at a time. So let's start with, let's name this group A, and that's not a G. Group B. Let's start with group A. We have 3 minus 1 squared. Work in the parentheses first. 3 minus 1 is 2. That leaves us squared. Plus, look at what we have over here. We have a fraction with an addition in the numerator, all inside parentheses. This has a group inside of a group. Where's the inside group? The inside group is this part right here. This is your inside group, the 2 plus 8. So within this group, we have a group that we are going to solve first, and then we can solve the outside group. This is called nested grouping. Nested grouping. All right. So nested grouping. We have, open parentheses, 2 plus 8 equals 10 divided by 2 squared. All right. Now, remember, we have two separate groups. I'm using my hand like you can see my hand. We have two separate groups right here. Group A and group... Why do I keep writing a B instead of a G? Group B. All right? So, group A, we have 2 squared. Group B, we have 10 divided by 2 squared. So, let's go ahead and solve these simultaneously this time. Remember, these are two separate groups. We can clearly see two separate groups. So we can do these simultaneously. So, all right, 2 squared equals 4 plus 10 divided by 2. What is 10 divided by 2? This leaves us with 5 squared. Now, 4, we can't do nothing with that yet because we have an exponent. 5 squared equals 25. And finally, we can now add 25 plus 4 equals 29. This equation looked like a little bit. It looked like it was a kind of difficult thing to work with. But if you take your time and just focus on each small part, one at a time, you will find that you can do these super easily. Make you feel good about yourself too. When you find yourself doing good, difficult problems, happens to me all the time. When I'm studying something and I'm able to solve a problem that's really difficult. Sometimes it took a couple of days for me to finally wrap my head around a problem, a single problem, a little problem like that long, and it took me several days. And after you finally get it though, you feel like a champion. Let's try one more problem. All right, check this crazy one out. I see a lot of stuff in here, right? 5 plus the square root of 9 cubed divided by the cube root of 64 squared plus the square root of 4 squared. What is this? What is all this? We got all kind of stuff inside of a division problem. What are we going to do here? What we're going to do is we're going to start with the groupings. Realize we have a numerator and a denominator. One at a time, right? One at a time. Or simultaneously. I'm going to do it simultaneously. Pause the video and try to do this yourself. See what you got. See what you think, if you think you can do it. I think you can. We've been through already in the previous videos. You should definitely be able to. So, we can't do nothing with the addition. So let's carry over of 5. So we have 5 plus the square root of 9 times 3. What do we have here? We have a square root inside of his parentheses. Let's do the parentheses first. So this gives us 3 cubed divided by, that's a big number, 64, right? That's a big number. The cube root, what is that asking? What number times itself 3 times equals 64? Well, let's find out. We know 1 times 1 times 1 ain't it, right? So what about 2 times 2 times 2? What does this give us? It gives us 2. This gives us 4 times 2, which equals 8. Not it. So we know 2 is not the cube root of 64. What about 3? 3 times 3 times 3. This gives us 9 times 3, 27. Not it. So let's try 4. 4 times 4 times 4. 16 times 4. What's 4 times 16? Let's find out. 24, 4, 5, 6. 64. So the cube root of 64 is 4. And we found that using basic arithmetic. You didn't even need a calculator for big numbers like that. You really don't. So we got 4 squared. We can put parentheses there if you want. Plus, what's going on here? Now we have an exponent inside of the square root. Remember, your square root is still a grouping. So let's work with the inside first. So what is 4 squared? 16, right? Now, we see a few more work that needs to be done before we can add these numbers together. So we have 5 plus, what is 3 cubed? 3 cubed is 3 times 3. We did that a little while ago when searching for the cube of 64. We should know or remember it was 27 divided by 4 squared. 4 times 4. 16 plus the square root of 16. Think about it. It's the inverse of 4 squared plus 4, right? Cool, huh? All right. Now we can add. I did my math wrong. I ended up with something I didn't want. This 5 was supposed to be a 3. Oh well, we're going to flow with it. All right. So what does this give us? 27 plus 5 equals 32 divided by 16 plus 4 is 20. Now we have a division problem. This is outside of my notes. This was supposed to be 30. So 32 divided by 20. What do we get? When I see even numbers like this, usually what I do is continuously divide by 2. So what is, and I'm doing the taboo thing by using this division symbol. What's 32 divided by 2? This gives us, I'm going to bring it down here, 16. 20 divided by 2 is 10. We still have even numbers. We can divide by 2 again. 16, this gives us 8 divided by 5. Yeah, my original was supposed to give us 30 over 20, which becomes 3 over 2, a much simpler problem. Well, we could sometimes think of 1.5, you know, but I didn't get that. For whatever reason, I used the wrong number. Oh well. Oh well. We still got an easy enough number to work with. What do you mean? We have 8 over 5, which is the same thing as saying 1.6, right? I'm not good with those kind of things, conversions in my head. 8 divided by 5. Yep, 1.6. I use a calculator all the time. I still have to sometimes. Those kind of numbers throw me off. I don't like doing the decimal transformations in my head. I don't like. Either way. That was order of operations. We're finishing that. The next level, Super Mario? The next lesson will be pretty much a rerun of order of operations, but involving variables. We're going to learn how to solve expressions or evaluate a certain expression when certain values change. That is the core behind this early algebra that we're studying. How something changes when a small number changes. How does that change the big picture? That is one of the core values of algebra. And it really continues on to calculus. So learn to love it if you want to do good at math. It's fun though. It's really fun. We're going to see much later how graphs change from a single number, increasing or decreasing. But that's there. That's not here. We're going to learn how to do arithmetic first. So with that said, I hope you enjoyed this. We are one step away from finishing chapter 1, properties of real numbers. After that, we'll be going to chapter 2, which will be exponents. The real exponents. We're going to start with, I said the real exponents, like I taught you something fake. Exponents with variables and stuff, and their laws and rules governing all that. So really cool stuff, really fun. I hope you look forward to it. So if you didn't understand anything I said, or maybe I ran over something too quickly, let me know in the comments below. Let me know how you think I did, how you think I could do better, or not do worse. And tell me what you learned. Tell me if you learned something new, or if you just simply enjoy looking at my weird face teaching something that I like. All right, see you there.